Now let us practically see how this casting works. Now I have a very easy example that demonstrates casting as well as a little more another concept along with this. I have a number, say byte A, say 4. Now you see, it's such an easy question to ask. If byte A is 4, well within the range, byte B is 4, well within the range, and I say byte C is A plus B, and we try to print out the result. Now anybody looking at this code will simply say the result is 8, because the value of 8 is again within the range of the byte. But as you can see, there is an error, and that says that it cannot convert from an int to a byte. Now where does this int come into picture? There's no int any near and there, there's no int. So where does this int come into picture? So what's happening here? Now what's happening here is, when you perform a calculation in Java, the minimum that you can do is a calculation is on an int. So this means you can't add 2 byte values. The calculation has to be on a minimum int scale. So what happens here is that A, which is a byte, gets promoted to an A, which is an int. B, which is a byte, gets promoted to a B, which is an int. So we get 2 numbers which are int and int. Now this is working because it's an upcast. If you just remember what we've just gone through, a byte to an int, and this is a automatic cast. So system is not asking you for the cast. So this is done automatic, this is done automatic, the result comes automatic, which is A plus B. The result is also a int. But when it tries to cast this value or store this value in a byte, it cannot do so, because an int value cannot be put down in a byte, and it automatically cannot cast a int value to a byte, because this is a downcast. Now we have a result in an int, and we're trying to store it in a byte. So this is a cast which requires explicit casting. So what we'll do is, I'll write a byte in front of this, and things are sorted. So such a small and easy program has so much of complexity associated with it, and this is what clears things about when automatic casting is being done and where you need an explicit cast. So now you can see C is now 8, and it's so easy to guess now the result is 8. So the other way around would have been if I say C is an int. So now we don't need any cast. C automatically is coming as an int, and we store it in an int, and things are balanced. So but we need to learn about explicit cast, so I need to show up how we can do this. So any value, if I say int k is equal to A, perfectly fine, because A is a byte. We are increasing the size to from 8-bit to 32-bit. There is absolutely no problem. If we go the reverse way, I say byte k is equal to k, there is a problem, because you cannot store a higher digit number into a smaller bit number. So we can do this, but you need to add a cast here. So this is all we need to know about upcasting and downcasting. Upcasting goes automatic, downcasting you need to add a cast, and for upcasting there's nothing the system will ask you for, and for a downcasting it will always wait for you to add a downcast.